Hello Jeeval, let me show you how to solve 4b. So there is uh, one point you are missing. So let me show you how I do this. So we want to solve this inequality, right? Figure out when which intervals this is true. So this is one function, this is another function, and we want to know for what values of x this is bigger than this, right? That's the objective. Okay, so first we try to see what these curves look like, right? So we draw the number line and figure out what are the interesting points, x. So this basically goes to infinity at x equal to minus 3. So we'll have something interesting happening at minus 3. um Similarly, this blows up and this goes to infinity when x is minus 5. So we'll have something interesting happening at minus 5. And then we want to check when these things are equal. So um, what we really want to find is, this greater than this, or this minus this is greater than 0, right? So let's just write it out. So we want 1 over x plus 3 minus uh, 1 over 2x plus 10, this to be greater than 0, right? This is our final objective. So we are gonna maybe give it a name, call it fx or something. Okay, so we want to um, find out where this becomes equal to this. Okay, so if this is not going to 0, if this is not going to 0, that means we are not at this point or this point. Then we can just cross multiply. So we can get x plus 3 equals 2x plus 10. So this basically becomes x equals minus 7, right? So this is also an interesting point. This is where these two curves will intersect. Like whatever the curves these are there for this and this, they will intersect at this point and no other point. This is important to understand. These two curves will intersect at this value of x and no other value of x. So one curve will come like this, the other curve will come like this, and there will be an intersection at x equal to minus 7. This is what it means to solve this equation. So minus 7 becomes an point of interest. So it's good to quickly try to draw these curves, okay, because it gives us intuition. So let me make some vertical lines. We will not make a vertical line here because it's a point of intersection. It's not a point where any of these goes to infinity. Okay, so now let's draw our curves. So 1 over x plus 3, this goes to infinity at x equal to minus 3. So it's gonna look like this. It's gonna come like this, go to infinity like this, and it's going to uh, come like this and go like this. Okay, right? So this is our first curve. The second curve is 1 over 2x plus 10. It goes to infinity at x to minus 5. So it's gonna look like this. It's positive to the right and negative to the left. So it's going to, let's just draw it like this. It's going to go like this. Okay. So now first question is, can this intersect? Can it go like this? The answer is no. It cannot intersect the x plus 3 curve. It's always going to be under it. Why? Because the only place it can intersect is x equal to 7. So we don't worry about an intersection on this side at all. Okay. So the other segment of the 5 thing is it's gonna come from minus infinity and go like this. Now this is interesting. In this part, they are going to intersect, right? We know there is an intersection at x equal to -7. So they are going to intersect like this. This is going to come from below and end up above. That's what it means to be intersecting. This second curve is going to come from below and intersect and go above, right? So you should have this intuition about intersections and where these segments lie with respect to the x-axis. So this was easy so far, right? And it is going to be easy from here on onwards also. So this is the complete picture. Okay, so just to make sure we identify the curves, so for 1 equal to x plus 3, I'm gonna shade it a little, like this is this segment and this segment. They basically belong to this function. Okay, and the other two segments are for the other function. So I do this just so that I can easily tell this matches, like these two belong to the same curve. Okay, so that's our picture. Now let's make our table. So the table is going to have exactly this shape, the shape you drew. So let me just replicate it here. So the interesting intervals are, there are 4 intervals. There are 3 points. So it's gonna cut the x-axis into 4 pieces. Uh, X values to the left of this, and then in this interval, then this interval, and this to the right of -3. So let's just draw those things. So 1, 2, 3, and maybe 4. Okay, so this is the interval x is less than -7, then -7 less than x less than -5, -5 less than x less than -3, and -3 less than x, right? These are the 4 intervals. Now let's draw our 2 functions. We'll pick the same ordering. So in here you are not writing this. The proper thing to write is actually, we want the sign of our functions. Our functions is, this is our function, sorry, this is our function, and this is our function, right? So we are actually writing the sign of 1 over 2x plus 10. In this case it does not matter, you could write 2x plus 10 because the numerator is positive, but the proper thing to write is write the full function 1 over 2x plus 10. This is the proper thing to write, because if the numerator was negative or something, doing it, writing just the denominator will give you the wrong answer, so let's just be proper. So this is what we want to find the sign of. This is our function, and the other function is 1 over x plus 3. Okay, so let's make a row for that, 1 over x plus 3. Okay, and then the third row will be this function of ours, this minus this. So we want 1 over x plus 3 minus 1 over 2x plus 10. Okay, and we are looking for the intervals where this turns positive. Okay, so now knowing the picture, we can very easily fill up this table. Okay, so let's see how to do that. Let's start. I like to start on the right. X is greater than -3, right? So it's on this side. So pick a value greater than -3. Let's say 0, right? 0 is the easiest value. So for this, let's just pick the value 0. What happens? So this becomes 1/10. This becomes 1/3. So both of them are positive, and 1/3 is bigger than 1/10, right? At x equal to 0, which is in this, we can pick any point in this interval. So x equal to 0 is a fine value. So at x equal to 0, this is 1/10, this is 1/3. So this is 1/3 minus 1/10. 1/3 is bigger than 1/10, so this is positive, right? So we get our positive sign, right? So this is good. Now we move from right to left. We cross over into this interval. Sorry, cross over into this interval. Right. So this is we are in this interval now. Okay. Now we are crossing over from here to here. So the only real change is that's happening is for this particular curve, for the x plus 3 curve, right? 1 over x plus 3 curve that is going through this, it's infinity, this kind of a line, asymptote, right? So okay, going from right to left, for this nothing changes. This function is not going from positive to negative. This basically it was positive, so it continues to be positive. Okay, this one is going through this kind of a thing. It was positive and now it's negative, right? So this is going to be negative, and you did this correctly in your solution. What happens here? Is the 1 over x plus 3 bigger than this? Well, it can't be, because this is negative and this is positive, so it cannot be, right? So this is negative, this is positive, it cannot be bigger than this, right? So this is not true. Okay, all good. So this also you did correctly. Now let's go one more step. Let's cross over this boundary of -5. Okay, so now we are in this range between -5 and -7. So what is going to change? All that's going to change is um, we are crossing over this asymptote for the second curve, the 2x plus 10 curve, right? So this is going to turn from positive to negative here. Okay, this one is going to stay negative, right? Nothing is changing, the sign is not changing. It's for this particular curve, so this is going to stay negative. Okay, now what happens here? Both are negative. It's we have to think a little bit to figure out which one is higher and which one is lower. Okay, so this is where we pay attention to our picture. Look at the picture. This was the x plus 3 curve, this was the 2x plus 10 curve. It is coming from below and crossing, right? So the x plus 3 curve, this is higher than the 2x plus 10 curve. So for this reason this is positive. Okay, for this reason this is positive, and you did this also correctly. Okay, now we are gonna switch to this side. So pay attention to what happens. There is a crossover. So nobody is changing sign. So this is negative, it will stay negative because it's not an infinity kind of a point for it. This stays negative, right? But this is a crossover. This is a crossover. So this was positive, so it is going to turn into a negative. This is where you made the mistake, because it's a crossover point. It is going to cross over like this. So the rule is not just you pay attention to this minus minus and it becomes a plus. That's not the rule. I think you have to pay attention to what's happening. Is this a crossover point or not? Okay, so that's why this is negative. This was positive. It's a crossover point. -7 is a crossover point. So this plus is going to change it to negative. That's what it means to be intersecting and flipping. Like this curve was under this. Now going to the left of it, this curve is over it. So the ordering is changing as you go through this point. So that's our answer. This function is positive only in this one and this one, positive and positive. That's our answer. So no three curves. Okay, so I'll leave you with this.